8.3, number 11. There's 3 parts to it on page 520. Consider the sequences defined by b sub n is 5 plus 1 over n squared. C sub n is n plus 5. They just chose some letters. First one, does the limit as n goes to infinity of b sub n, does it exist? If so, give its value. Okay, so I can rewrite this as the limit as n goes to infinity of 5 plus 1 over n squared. I can break this up into the limit as n goes to infinity of 5 plus the limit as n goes to infinity of 1 over n squared. Feel free to pause whenever you need to. Okay, I know I can't zoom out too much from where I'm at. So I replace b sub n with its actual phrase. So this is technically on parentheses if that helps your brain. I can split these up because they're being added. So I put the 5 by itself and put the 1 over n squared by itself. This is saying I have y equals 5. That's 5. I have a line at y equals 5. What's the end behavior? As I go towards infinity, what's the line going to approach or hit? 5. So the limit of that is 5. If I have n squared, so 1 over n squared looks like that. If I'm going towards infinity, what is this approaching? 0. Because infinity in the denominator is going to get huge, especially if it's squared, and 1 over a huge number is going to be basically 0. So the limit does exist and 5. So limit exists 5. You could also say it converges. It didn't specifically say for converge, it said does it exist, yes or no, and then tell me the value. Okay, part B then wants to know, does the limit as n goes to infinity of c sub n exist? So limit n goes to infinity n plus 5. Now we don't have to split it up, we can also think about this. So if I had split this up into limit as n goes to infinity of n, okay, so that's y equals n, that's that line. If I go towards infinity on my x-axis, what's happening to this graph? Does it converge anywhere? No, it keeps getting bigger and bigger and bigger. So this part's not going to have a limit. This limit will be 5. But can you add does not exist with 5? No. So the limit itself does not exist. Then for part C wants us to multiply them together. So let's do that out here. B sub n times C sub n. So if I have 5 plus 1 over n squared times n plus 5. Remember to, FOIL is not a verb, but remember to distribute. So I'm going to have 5n plus 25 plus n over n squared plus 5 over n squared. I'm not going to actually, okay, we can simplify this. Yeah, I'll do that. I'll simplify it. So I have 5n plus 25 plus 1 over n plus 5 over n squared. I'm going to take this and rewrite it with limit form, with limit notation. Okay, so I want the limit as n goes to infinity of 5n plus 25 plus 1 over n plus 5 over n squared. Now let's see what limits we know from this. If n is ever in the denominator and it's just a constant on top, those go to 0. So I don't care about them, they disappear. Pause here if you need to think about why they go to 0. 25 limits 25. But 5 times n, so 5 times n, if I put in 5n, y equals 5n, it's more of a steep curve, but it just keeps getting higher, it keeps getting higher and higher and higher and higher and increases. That is a does not exist. So, it should not exist. Equals d and e. I don't know why the book says limit exists is 0, because it shouldn't, unless they didn't distribute. Because you can't multiply them because part B does not exist. If part B was 0, then I can see why C with that. But so don't trust the book's answer for C. It should be D and E. Does not exist. You can also write out the words does not exist. All right, 8.4, number 11. 8-4 number 11 is summation I equals 1. So index of 1, my upper bound is at 1,000, and I want it of the argument I. So I'm going to plug in 1 for I. Then my index increases to 2. Plug in the 2. Then my index increases to 3. I'm going to do that all the way up to 1,000. Is this arithmetic or is this geometric? It is a series because I'm adding everything up. Summation, capital sigma, and it is arithmetic with a common difference of positive 1 because I'm adding 1 each time. So my formula would be S sub n is n divided by 2, a sub 1 plus a sub n. In this case, n is going to be 1,000. Okay, watch these two numbers. I don't think your book or your test is going to be any funky, but it is possible later in life to see them be tricky. If this starts at 0, then this is actually 1,001 because 0 to 1,000 is 1,001 numbers you're plugging in. So just watch that in life. First term, 1. Last term is 1,000. That should be a plus sign. So 1,001 times 1,000 should, divided by 2. Sorry, divided by 2. Oh. I went ahead and started putting this in without actually writing all the information. N is 1,000, your first term, your 1,000th term. Plugged it in, and you should get out 500,500. So, yeah. That was 11. All right, 8-7. I'm going to make a separate video just because it's 3 problems.